On October 29th, 2025, something impossible happened. The interstellar comet 3I Atlas hit perihelion, its closest brush with the Sun, and in those fevered hours it did what no natural comet ever should. It flared 5 times brighter than predicted. Not a slow crescendo, not a gentle surge. An abrupt, violent blaze of blue that punched through the darkness like a signal flare. Data streamed in from observatories worldwide between October 31st and November 4th. Scientists triple-checked the photometry. The brightening was undeniable, yet the implications were catastrophic. Basic physics says comets brighten by bleeding mass. Solar heat turns buried ice into gas, gas into a glowing coma into a tail. A 5-fold luminosity spike demands at least 13% of the nucleus be vaporized in days. That's not a puff of dust, that's a cataclysmic hemorrhage. Every telescope on Earth and in orbit should have seen a monstrous envelope of debris ballooning outward, a shimmering halo hundreds of thousands of kilometers wide. Instead, the post-perihelion images are eerily clean. No colossal gas cloud, no debris field, nothing. 13% of the comet simply vanished without a trace. Harvard's Avi Loeb ran the numbers on momentum conservation. The tiny, inexplicable acceleration detected in 3I Atlas's trajectory required thrust. For a natural comet, that thrust comes from rocket-like jets of sublimating ice. To produce the observed push at normal thermal speeds, the comet had to eject more than 13% of its mass. But if the material was expelled at far higher velocities, say by something artificial, the same acceleration could be achieved with a fraction of the loss. That's the knife-edge paradox. Either we're blind to a gas cloud the size of Jupiter's magnetosphere, or the force wasn't from ice at all. Then there's the second intruder, C 2025 K1 Atlas, a native Oort cloud comet, not interstellar, yet equally defiant. It screamed past the Sun on October 8th at just 31 million miles, close enough to be shredded by tidal forces and roasted into oblivion. Experts gave it hours, maybe days. It emerged intact. More than intact. Transformed. Astrophotographer Dan Bartlett caught it from Dune Lake, California, and the frames show a tail sheathed in molten gold. Not the usual cyan from cyanogen, not the emerald of diatomic carbon, not the pale white of reflected sunlight. Pure metallic gold, as if the comet had been dipped in liquid aurum. Comets don't do that. Their colours are chemical fingerprints, green for C2, blue for ionized CO, red for water ions. Gold has no place in the periodic table of tails. Something on its surface reflected sunlight with the warm, perfect sheen of polished metal. Something that shouldn't survive a solar furnace hot enough to melt titanium. 2 comets, 2 violations of everything we know. One that burned 5 times brighter, yet left no corpse. One that dove through hell and came back gilded. The data are public. The math is merciless. Blue materializes from ionized carbon monoxide. Red often signals organic compounds, yet gold demands something extraordinary. It signifies an absence. Spectroscopic readings from Lowell Observatory in Arizona verify what the color implies. C 2025 K1 Atlas is profoundly lacking in carbon-bearing molecules. Dicarbon, carbon monoxide, cyanide, the compounds present in nearly every documented comet, linger in mere trace quantities. Across the entire archive of observed comets, only 2 others have exhibited this degree of carbon depletion. The probability of discovering a third is astronomically remote. When carbon compounds vanish, the residual dust refracts sunlight in an altered manner. The outcome is that golden sheen, that uncanny metallic radiance. Researchers candidly concede they cannot precisely explain why this comet is bereft of carbon. It ought to have condensed from the same primordial reservoir as fellow Oort cloud denizens. Its chemistry should echo its kin, yet it does not. Both comets bear the Atlas designation. Both shattered forecasts. The interstellar interloper flared impossibly, without the anticipated gas outburst. The solar system native endured a predicted disintegration and resurfaced chemically aberrant. October 8th and October 29th, 3 weeks apart, 2 perihelia, 2 entities that defied expectation. The US government has fallen mute. NASA's customary torrent of data and imagery halted when the federal shutdown commenced on October 1st. The routine cascade of observations, the meticulous dispatches that accompany major astronomical phenomena, simply stopped. On October 31st, Congresswoman Anna Paulina Luna dispatched a formal letter to NASA's acting administrator, insisting on the disclosure of records, images, and data pertaining to 3 Atlas. She deemed them material vital for comprehending interstellar visitors and their interplay with our solar system. NASA slated a conference call with her for November 6th, nothing earlier. Meanwhile, the All-Domain Anomaly Resolution Office, the Pentagon unit established to probe unidentified phenomena, released a statement. They are tracking reports diligently, yet classify 3 Atlas as beyond their purview. It is categorized as a comet, thus not an unidentified anomalous phenomenon. Not their concern. But if it is merely a comet, why does it contravene the models? Why does one blaze gold absent the elements that should define it? And why does the other gleam 5 times brighter without dispersing the mass that physics requires? Lowe labels this a potential black swan event, most probably natural, he states, but the irregularities are substantial enough that we must entertain alternative explanations. The ramifications, should this prove anything other than a comet, would be momentous for humankind. From November 27th through January 27th, the International Asteroid Warning Network will launch a concentrated observation campaign. Telescopes worldwide will train on 3E Atlas as it recedes from the Sun, at last escaping the solar glare that has veiled it. They will assay its composition via spectroscopy, monitor any additional acceleration, hunt for that absent gas envelope. C-2025 K1 Atlas will reach its nearest Earth approach on November 24th, sweeping just 37 million miles distant. Backyard telescopes will resolve it clearly. That enigmatic golden ribbon weaving through the void. 2 comets, 1 designation, and behaviour neither should exhibit. The non-gravitational acceleration is the game changer. When the latest orbital solutions arrived on November 5th, they validated what had been whispered but never confirmed. 3I Atlas is propelling itself, subtly yet measurably, enough to rewrite the rules. The acceleration resolves into 2 clean components, both confined precisely to the comet's orbital plane, a radial thrust outward from the Sun and a transverse vector at right angles to it. No out-of-plane motion whatsoever. Nothing lifting the comet above or below its trajectory. Just these 2 forces, aligned like deliberate propulsion. The signal sits at 3.7 sigma above noise, robust in astronomy, where 5 sigma is gold but 3.7 demands attention. Ignoring it means discarding evidence. The values were normalized to 1 AU, Earth's distance from the Sun, stripping away distance-dependent solar radiation effects. Even after correction, the forces persist. Natural comets do exhibit non-gravitational kicks, sublimating ice blast gas jets from random vents, tiny thrusters firing as the nucleus spins. Those accelerations are noisy, inconsistent, chaotic, exactly what physics predicts from a dirty snowball. But 3I Atlas is different. Its forces stay steady in direction, locked to orbital geometry, demanding sustained massive outgassing no natural body could sustain without visible coma or tail during the critical window. From July through September 2025, 4,022 observations from 227 observatories worldwide showed 0 non-gravitational deviation. None. The comet ghosted along a perfect gravitational arc, answering only to the Sun and distant planetary whispers. Then it rounded perihelion, whipped past the Sun, and the forces ignited. Something activated. Spectroscopy in October delivered the next shock. 3I Atlas carries far more nickel than iron. That ratio is inverted. Every known comet, asteroid, and rocky fragment in the solar system shows iron dominance, the fingerprint of stellar fusion and nebular condensation 4 billion years ago. Iron outweighs nickel because stars forge more of it. Everything native to our system inherited that bias. Yet 3I Atlas flips the script. Its Ni-Fe ratio mirrors human-engineered high-nickel alloys, Inconel, Hastelloy, Monel, materials forged for turbine blades, rocket nozzles, and re-entry shields that laugh at extreme heat and corrosion. Its nickel to cyanide ratio towers orders of magnitude above any comet on record, dwarfing even 2I Borisov, our previous interstellar tourist from 2019. Something switched on, and it wasn't born here. Cyanide is common in comets. It forms naturally from carbon and nitrogen in the cold depths of space. Finding abundant nickel, but relatively little cyanide, inverts the expected chemistry. The water content is equally strange, only 4% by mass. Comets are typically described as dirty snowballs, huge chunks of ice mixed with rock and dust. Water dominates their composition. It's what makes them comets rather than asteroids. But 3I Atlas is dry. It has some water enough to confirm its outgassing, but nowhere near the levels that define cometary bodies, 4%. That's closer to an asteroid's moisture content. Yet it has a tail. It brightened dramatically. It's shedding material. The polarization measurements are unprecedented. When light scatters off a comet's dust, it becomes polarized with the electric field waves oscillating in preferred directions. The degree of polarization tells us about the dust particle sizes and composition. Every comet measured shows positive or mildly negative polarization depending on the viewing angle. 3I Atlas shows extreme negative polarization. Nothing else does. Not 2I Borisov. Not any solar system comet in the catalogue. The light bouncing off its dust is polarized in a way that defies the standard models. Scientists calculate the probability of this occurring naturally at below 1%. Below 1% doesn't mean impossible, it means rare, exceptionally rare. And when you start stacking these rarities together, when you accumulate anomaly after anomaly, the compound probability drops further. Nickel over iron, nickel over cyanide, 4% water, extreme negative polarization, no gas cloud despite massive brightening, non-gravitational acceleration, appearing only at perihelion. Each individually could be explained away. Together they form a pattern. The trajectory presents its own puzzle. 3I Atlas entered the solar system on a retrograde orbit moving opposite to the direction planets travel. That's not impossible for an interstellar object, but its orbital plane aligns with the ecliptic to within 5 degrees. The ecliptic is the flat disk where planets orbit. Most objects coming from random directions in interstellar space would cross that plane at steep angles. They'd come in from above or below, diving through at wild inclinations. But 3I Atlas glides along nearly parallel to it. The probability of that alignment occurring by chance sits at 0.2%. 1 in 500. Could happen. Rare but possible. Its arrival time also raises questions. The comet's trajectory brought it within tens of millions of kilometres of Mars, Venus, and Jupiter. Not collision courses, but notable approaches. And its perihelion occurred when Earth's position made direct observation impossible. The sun blocked our view during the critical passage. If you wanted to visit the inner solar system while minimizing detection, while getting close looks at multiple planets, this trajectory would serve that purpose. The probability of such a path occurring randomly, 0.0%, 1 in 20,000. Avi Loeb has been documenting these statistical anomalies since the comet's discovery. He's careful to emphasize that low probability doesn't prove artificial origin. Unlikely events happen. The universe is immense. Curious coincidences arise organically. Yet he observes that rejecting the chance demands overlooking the evidence. Science progresses by evaluating every hypothesis, aligning with the data, not merely the reassuring ones. The forthcoming observation effort will scrutinize the natural comet theory head-on. Should 3 Atlas prove natural, the post-perihelion phase ought to uncover that absent gas cloud. 13% of its mass needed to dissipate somewhere. The cloud should be dispersing, luminous, observable across various wavelengths. Spectroscopy will pinpoint the molecules. Imaging will depict the form. If the cloud is absent, if the data yield no signs of substantial outgassing corresponding to the brightening and acceleration, then the natural account collapses entirely. Not merely grows improbable, and should that occur, what endures? The scale contrast conveys its message. 3E Atlas is enormous, about 1 million times weightier than Oumuamua, our inaugural interstellar interloper spotted in 2017. 1,000-fold denser than 2I Borisov, and it travels swifter than either. That pairing is statistically rare. Massive bodies usually proceed more deliberately. They originate in steadier settings, accrue greater substance, and avoid expulsion from their origin systems at extreme speeds. Tiny objects get hurled out readily. A gravitational clash with a gas giant can propel a small pebble into interstellar voids at high velocity. But shifting an entity the size of 3I Atlas demands far more energy. The odds of an interstellar body boasting this bulk while achieving such velocity, under 0.1%. And still it arrives, the third interstellar object we've ever identified, defying the precedent established by the prior pair. There's yet another facet concealed in the Hubble Space Telescope data from July. The photographs depict a teardrop-like formation encircling the nucleus, a sheath of dust trailing from the dense centre. But they also disclose something further: ejector directed toward the sun. Comets don't behave that way. As a comet nears the sun, solar rays warm the sun-facing aspect. Ice sublimates, gases burst forth, and the ensuing jet propels outward from the heat origin. Invariably outward, the gases and dust flow along the thrust's path, away from the sun. That's the reason comet tails consistently orient away from the sun, irrespective of the comet's trajectory. Yet 3I Atlas exhibited a jet oriented toward the sun. No visual deception, no angular viewpoint ruse. The examination verified it was authentic. From July to August, substances were verifiably advancing sunward from the comet's core. Natural. Rationales persist. Comets possess intricate contours, irregular exteriors featuring ridges and depressions. An outlet on the shadowed flank might expel matter that subsequently arcs around the nucleus, seeming sunward from specific perspectives. Spin dynamics could generate atypical configurations. These aren't unattainable situations, but they append to the expanding roster. Yet another irregularity necessitating exceptional conditions. Yet another happenstance. Meanwhile, C2025 K1 Atlas persists in its spectacle. The aureate comet, the endurer, the element-starved enigma. They don't demand wild theories, yet they keep piling up. Each oddity demands its own excuse. The path needs one story. The makeup needs another. The speed boost needs a third. The schedule needs a fourth. Pile enough excuses on top of each other, and the ordinary answer ends up as convoluted as any exotic rival in sheer improbability. This is where Avi's black swan idea kicks in. Science usually handles white swans, things we predict, stuff that slots neatly into what we already believe, data that just nods along. When something weird shows up, we first try to squeeze it into the old boxes. We ought to. That's solid science. But every now and then a black swan waddles in. Something so rare, so out of left field, that it forces us to redraw the boxes. Continental drift was a black swan. Plate tectonics spat in the face of the fixed continents geologists had sworn by for centuries. Quantum mechanics was a black swan. Tiny bits acting like waves and particles at once broke every rule of old-school physics. Black swans never wear name tags. They start as glitches, flukes, bad readings. Only when the proof stacks up, when separate teams keep seeing the same weirdness, do we admit we're looking at something brand new. Are these comets black swans, or just odd white swans that happen to share a bunch of quirks? The data we grab between November 27th and January 27th will nudge us toward an answer. When C2023 A3 Atlas finally steps clear of the sun's glare. When scopes can stare at it without solar static, the puzzle pieces will either click or the riddle will grow teeth. And C2025 K1 is sliding toward its closest brush with Earth in 3 weeks. November 24th, Thanksgiving week, that golden streak across the sky, visible to anyone with binoculars, and a cloudless night. 2 Atlas comets, 2 dates, 2 riddles still unsolved. One last detail about C2023. A3 Atlas barely gets a whisper outside the inner circles. Its inbound vector, the spot on the celestial sphere it came from before it ever knew our sun existed. In August 1977, the Big Ear radio telescope at Ohio State caught a fierce, narrow-band burst from deep space. It rang for 72 seconds, dwarfing the usual cosmic hiss, with traits that screamed artificial origin. The astronomer on duty was so floored he scrawled, "Wow," right on the printout. The burst never came back. 40-plus years of staring at that same slice of sky turned up zilch. The wow signal originated in the direction of Sagittarius, hard by the Sagittarius-Scorpius border. Experts have argued about it ever since. Natural culprits exist. Comets can belch hydrogen clouds that ring at the exact same frequency. Earth-based interference remains a suspect. but no smoking gun ever appeared. C 2023. A3. Atlas came barreling in from a heading that lines up with the WOW source to within 9 degrees. 9 degrees isn't pinpoint. It's about 18 full moon widths. A big patch, sure, but not random. The odds of an interstellar visitor drifting in from that same neighbourhood purely by luck sit at roughly the 0.6%. Does that mean C 2023 A3 Atlas is tied to the WOW signal? No, not necessarily. Not even probably. But it adds to the list. Another low probability occurrence. Another data point that wouldn't be remarkable alone, but becomes intriguing when combined with everything else. If you were designing a probe to visit another star system, what would you want it to do? Survey the planets, measure their properties, approach close enough to gather detailed data, but not so close as to be destroyed by gravitational forces or detected easily. You'd want it robust, built to survive the journey through interstellar space. You'd make it from materials that resist radiation damage and temperature extremes. Nickel alloys fit that requirement. They handle thermal stress well, they don't corrode easily. They're stable across wide temperature ranges. If an advanced civilization sent a probe through the galaxy, nickel alloys might be part of its construction. You'd also want the probe to be efficient with resources. Carrying massive amounts of fuel across interstellar distances is impractical. Light sails, ion drives, or other low-thrust propulsion systems make more sense. You'd activate them only when necessary, conserving energy during the long cruise phase. When approaching the target star, you'd need propulsion for course corrections, orbital adjustments, controlled maneuvers that match the acceleration pattern. None during the approach. Activation near perihelion. Forces aligned with the orbital plane, suggesting directional control rather than random outgassing. The water content also fits. A probe wouldn't need to be made of ice. It might have some water for cooling systems or as reaction mass for thrusters, but the bulk would be structural materials and instruments. 4% water makes sense for technology. It doesn't make sense for a comet. This is speculation. It's building a narrative from anomalies. Scientists rightly resist this kind of reasoning. Data points don't prove a hypothesis. They suggest possibilities. The natural comet explanation still holds for each individual observation if you grant enough special circumstances. But consider the alternative framing. If someone showed you an object with all these characteristics and asked you to identify it without knowing the context, what would you conclude? Nickel-rich, water-poor, minimal carbon, extreme negative polarization, controlled acceleration appearing on schedule, trajectory aligned with planetary orbits, and time to minimize Earth observation at critical moments. Would you immediately think comet, or would you think something else? The government's silence matters more than it might seem. NASA has observed thousands of comets. When something interesting happens, they release data, images appear on official websites, press releases go out, scientists give interviews, the public gets informed. With 3 Atlas, that flow stopped. The shutdown provides convenient cover. Agencies close, data release halts, and everyone accepts it as bureaucratic dysfunction rather than policy. But Congresswoman Luna's request specifically asked for scientific data critical to understanding interstellar visitors. That phrasing suggests urgency beyond routine curiosity. An IRO's statement is revealing in what it doesn't say. They're monitoring reports closely. They classify it as a comet, therefore not a UAP, therefore outside their mandate. Yet if they're tracking it intensively, they've witnessed the identical irregularities that the rest of us have recorded. They grasp the probabilities. They recognise the consequences. Labelling it a comet simply because it resembles one is circular logic, when the core issue is whether it truly is one. We refrain from investigating because we've already deemed it natural, begging the very question that demands scrutiny. This may all stem from procedural restraint. Government bodies proceed deliberately. They adhere to protocols. Cross-agency dialogue demands official pathways. The shutdown has legitimately paralysed workflows. None of this confirms conspiracy or suppression. But it does elevate the importance of independent confirmation. The International Asteroid Warning Network's coordinated observation effort now becomes pivotal. Researchers beyond governmental oversight, deploying instruments across the globe, collecting data that cannot be withheld or deferred. Between November 27th and January 27th, we will have evidence, not conjecture, not probabilistic debates, not competing readings of proxy indicators. Direct imaging of 3I Atlas at numerous wavelengths from diverse sites by independent teams. If the anticipated gas envelope materializes, if spectral analysis reveals standard cometary composition, if the acceleration aligns with discrete outgassing jets on the nucleus, then the natural model prevails. The irregularities were genuine, yet resolvable. We gain insight into cometary variation. Science progresses. If the envelope never forms, if acceleration persists, absent matching gas emission, if the chemistry proves incompatible with known formation processes, then we confront something unparalleled. Not definitive proof of artificial design, but collapse of every natural hypothesis. And when natural, hypotheses collapse, alternative explanations must be entertained. C-2025 K1 Atlas could prove essential to interpreting its interstellar twin. Should both bodies exhibit carbon depletion, should both display anomalous metal enrichment, should both manifest traits at odds with standard comets, then the shared Atlas designation transcends coincidence. It signals a trend. One golden comet from the fringes of our system. One brilliant blue interloper from another star, both emerging in the same year. Both discovered by the same survey. Both defying established paradigms of chemistry and dynamics. Amateur astronomers globally are monitoring both objects. Telescopes in gardens, on balconies, at campus observatories. Hundreds of autonomous observers capturing frames, recording photometry, uploading datasets in real time. That decentralized web ensures resilience against narrative control. The information resides beyond any lone organization's reach. November 24th will be decisive. When C-2025 K1 reaches perihelion and closest Earth approach, it will peak in brightness and resolution. If parallels intensify, if fresh discrepancies surface, the amateur grid will flag them. Then professional facilities will verify or debunk. At that point, NASA must address the findings, shutdown or not. At that point, the broader scientific community must align theory with observation. 20 days remain until C-2025 K1's nearest pass. 22 days until the concentrated campaign commences for 3I Atlas. Under 1 month until we learn whether these are exceptional comets or something altogether different. The universe has delivered 2 envoys, both bearing the name Atlas, both shattering our assumptions, both posing questions we were only starting to whisper. What they reveal hinges on what we're prepared to accept. History warns us to doubt. The cosmos has tricked us before. Pulsars were once mistaken for alien signals until we recognized them as spinning neutron stars. Vikings' Mars experiments hinted at biology until earthly contamination and peroxide chemistry offered simpler answers. Oumuamua ignited talk of solar sails until rotational tumbling and hydrogen outgassing supplied natural causes for its push. We've disciplined ourselves to drain every ordinary possibility before daring the extraordinary. That restraint safeguards science. It stops us from christening ignorance as breakthrough, from labelling the unexplained as inexplicable. Yet that same restraint can harden into a cage. When something truly alien arrives, our obsession with familiar causes can blind us to the obvious. The real question isn't whether to doubt, it's whether our doubt accelerates discovery or strangles it. With these twin Atlas comets, the dilemma stares us in the face. The evidence is public. The measurements are solid. C-2024 S1 Atlas flared 5 times brighter at closest approach to the Sun, without spawning the massive gas shroud physics demands. It exhibits semonmatiti, non-gravitational thrust that switched on precisely when required, perfectly aligned with its orbital path, implying guidance instead of randomness. Its makeup flips natural abundances on their head. More nickel than iron, more nickel than cyanide. A chemistry that echoes terrestrial metallurgy far more than primordial ice. C-2025 K1 Atlas endured heat and tidal forces that should have pulverized it. It morphed into something scarce, something aureate, something stripped of volatiles in patterns shared by only 2 prior comets in recorded history. It clings to brilliance long after it should dim, mocking every predictive model of cometary decay. Both bodies share a designation, a detection network, a schedule that paraded them across our skies mere months apart. Each anomaly alone strains conventional theory. Together they snap it. The natural comet story now demands a cascade of coincidences. Each oddity requires its own improbable asterisk. The orbit had to thread an exact needle. The composition had to be sculpted by eons of cosmic ray bombardment. The timing had to synchronize by sheer luck. The thrust had to vent from invisible nozzles no instrument has glimpsed. The absent gas envelope had to evade every spectrograph trained upon it. Individually conceivable, yes. But stack rarity upon rarity upon rarity, and the joint probability collapses. At what threshold does the pile-up of special pleading become less credible than the alternative? This is the unsettling crux. Not do extraterrestrials exist, not have they come calling, but have we so fetishized naturalistic accounts that we dismiss smoking gun proof if it drifted into view? If an interstellar artifact were real, what signature would it bear? Materials engineered for centuries of abuse. Propulsion fired sparingly, only at critical junctures. A flyby survey of habitable worlds, closing in for measurements while hugging the shadows. A payload almost bone dry of volatiles, carrying just enough for attitude control and course correction. That description fits the 3 Atlas hypothesis better than the comet hypothesis does. And C-25K1, perhaps it's exactly what it appears to be. An unusual but natural comet from the Oort cloud, chemically distinct from typical objects. Surviving perihelion against predictions through sheer structural strength. Its golden hue, its carbon depletion, its sustained brilliance, all explicable through rare but natural processes. Or perhaps its discovery 3 months before the interstellar visitor isn't coincidence. Perhaps 2 anomalous bodies sharing the Atlas name and defying expectations in the same year mean something deeper. Perhaps 1 golden messenger from our system's edge and 1 blue messenger from another star represent a pattern we're not yet ready to acknowledge. We don't know. That's the honest truth. We have data that strains natural explanations without proving artificial ones. We have anomalies that stack into patterns without resolving into conclusions. We have observations that demand attention without delivering certainty. The coming weeks will bring clarity. When C-2025K1 swings past Earth on November 24th, instruments will dissect it in unprecedented detail. When the observation campaign launches on November 27th, 3i Atlas will face scrutiny from dozens of telescopes across every wavelength. The missing gas cloud will either materialize or its absence will be locked in. The acceleration will either trace to natural outgassing or remain unexplained. The chemistry will either fit cometary models or keep defying them. And then we'll know. Not everything, but far more than we know now. Enough to ask sharper questions. Whatever these objects are, they've already achieved something extraordinary. They've forced us to confront our assumptions. They've exposed the cracks in our models. They've proven that the universe still hides surprises, that our catalogue of natural phenomena is still incomplete, that the cosmos runs on scales and timelines and mechanisms we're only beginning to grasp. If they're comets, extraordinary comets, then we've learned that objects from interstellar space and from our Oort cloud can display chemistry and behaviour far more diverse than our theories ever predicted. We've learned that our models need revision, that edge cases lie beyond our data sets, that rare conditions breed rare outcomes. If there's something else, something we haven't dared name yet, then we've learned something even more profound. We've learned that we're not alone in asking questions. That intelligence might appear in forms we never imagined, that the universe contains not just physics and chemistry, but perhaps intention and design. Both possibilities stretch our understanding. Both demand we think more rigorously, observe more patiently, stay open to evidence wherever it points. The night sky has always held mysteries. Ancient humans saw patterns in stars and imagined gods. Modern humans see patterns in data and imagine natural processes. Both approaches hunt meaning in what we witness. Both try to explain the scene. These 2 Atlas comets have handed us fresh patterns to ponder. 2 objects, different origins, shared strangeness. 1 golden, 1 blue. 1 from our solar system's fringe, 1 from the void between stars. Both discovered by automated sentinels scanning for danger. Both arriving when our instruments could catch them, yet not instantly explain them. They're still out there right now, gliding through the dark, reflecting sunlight, carrying whatever secrets their composition and motion encode. Amateur astronomers are imaging them tonight. Professional telescopes are pinning their positions. Instruments are measuring their spectra. Data is piling up. In 20 days, C2025 K1 will skim past Earth at closest approach. In 22 days, the intensive campaign to study 3I Atlas begins. In the weeks and months after, papers will drop, debates will ignite, theories will crash against observations, and we'll stand closer to understanding what these messengers, these heralds, these anomalies truly are. Two comets named Atlas, two enigmas cloaked in data, two invitations to doubt everything we thought we knew about the universe and our place within it. The answers are coming whether we're ready for them or not.